Good afternoon. I'm Tim Nyerges from the University of Washington. We're going to have a panel, as it says here on the slide. This is Synergies of CyberGIS and Geodesign. And I want to thank Mike Goodchild for doing such a great job this morning in his keynote to actually lead into this topic about what some of these synergies could be. And so we might be able to pick up on some of those ideas, hopefully from the audience as well, from you as participants during the discussion here. We have a distinguished panel here today. We have Clint Brown from Esri, long-term employee at Esri with strategic thinking in the way that the organization moves forward, very big in the area of CyberGIS and Geodesign. We have Naicong Lee from Nyerges, formerly of the University of Redlands Institute, but Nyerges is a new organization with Bill Miller and Naicong as the principals of that organization. And she leads the Spatial Decision Support Consortium, which is a organization that we'll hopefully hear a little bit more about in the months and years ahead as we try and organize a little bit more formally for that. We have Piotr Jankowski from San Diego State University, who you've heard just earlier here, and Rob Pahle from Arizona State University, who you've already heard as well. So we have a small collection of questions that we're going to address. It's a very small set, so hopefully, though, with a small set, there are some big ideas in a small set. So one of the things about structured participation is if you provide a lot of structure, then there may be a lot of participation, because generally, sometimes there is some confusion of what kinds of questions you might take up. So we were going to go in the order, I believe, of the nature of these questions, but it's open. It's a panel discussion, really is what it is. But I did provide these questions earlier. Perhaps maybe Clint might not have gotten them, as I just heard, Steve. But at any rate, we'll go with what we have here and briefly describe a recent past and or current activity of the CyberGIS community and or the geodesign community that has potential for fostering synergy for both communities. So the idea of community here is a little bit more broader idea to move this process forward here in terms of conversations. Do one of you want to volunteer to tackle that first one? Or do you want to start on the end, Naicong, and you'll just start it out? Yeah.
Is this on? Okay. First of all, I have to say I'm so happy to see a large and significant NSF-funded project that has an aspect of looking into solving real-world big problems, big challenges. It's not just, instead of just knowledge discovery and understanding, but really solving problems and design our future. And so, really happy about that.
I'm sorry, Naicong, I was thinking you might want to, each of you might want to situate yourselves a little bit in terms of your connection to these ideas here, just to relate a little bit of what you've done, and then that helps the audience know why it is we're talking.
Okay. During my time working at University of Redlands Institute specifically, I participated in several conservation planning projects. Our clients are mostly Fish and Wildlife Service and Army Corps engineers and so on, Forest Service and so on. I also led the development of spatial decision support ontology and the co-founded the spatial decision support consortium. And the ontology, by the way, is live and driving a knowledge portal. It's called Spatial Decision Support Knowledge Portal. You can Google it, and which includes a lot of good information regarding decision-making process and steps, and the workflows, the methods used during such processes, case studies, and a small collection of application tools and which implement various methods used during decision support. And we also sort of bootstrapped this spatial decision support ontology and made a geodesign ontology, which is hosted on the geodesign knowledge portal, which the content actually overlap a lot with the SDS ontology. So that is my my work, how it's related to this. I guess maybe anyway.
Okay,
So
we can essentially do the same thing then. We'll just go down. Clint, do you want to say a little bit about your work here?
So I'm Clint Brown, the Director of Product Engineering at Esri. I've been here 31 years building the products. My teams worked directly early on with Scott Morehouse's teams. He had software engineers. I had GIS analysts, app programmers, writers, testers, people like that. Together our teams built the product. More recently, Scott's taken a step back in the past year. Sud Menon has started to lead the product development, and I continue to work with him to do the same thing we've always done. A large part of GIS has been about really kind of all of us together having a vision for and evolving a kind of method, or at least a set of best practices to go forward. There's so much to figure out and so much to learn about this that I've become quite passionate about trying to think about how real customers could use GIS to solve real problems. So that's something that I've been paying a lot of attention to. Do we want to try to do this, or you just want to introduce?
We will, just
Okay.
As we
All right.
situate
Good.
everyone here.
I think I'm.
Oh, you still mic.
Do you hear me? Okay, great. I'm Piotr Jankowski. I come into this panel via geodesign, but geodesign is, if I trace my lineage, is many, many years past what I did before. And what I did before was research on how groups collaborate using GIS and GIS-like tools solving problems. So I come with quite a bit of research experience and some ideas on collaborative work engaging spatial concepts, spatial data, and spatial tools. And then when geodesign popped up some years back, it dawned on me very quickly that this was this idea of collaborating, solving problems in a collaborative fashion, but encapsulated using a different term and maybe having different tools at our disposal. So some of the questions that appeared in front of me when I looked at geodesign were old questions that I looked at in the context of collaborative GIS.
Thank you. Rob?
Hello, can you hear me? So I'm Rob Pahle. My background is actually in architecture and planning, so a design discipline. But I've worked for a few years at the ASU Decision Theater as the technical director for the place. So I did a lot on computational things and also visualizations. And now I'm working a lot on decision support systems, decision making, spatial decision making. So that's how I span these kind of topics.
Okay, I'm a co-principal investigator in the CyberGIS project, and I found Carl's work like Carl Steinitz in 1999, and wondered why he put 5 modeling phases before something called decision modeling, since I was working on group participatory decision modeling stuff. And so it was, I've tried to find something better since. I haven't found anything better since in terms of methodology. So as a framework for geodesign, now that he has that book published out there, I think it's still a great piece to orient the nature of what we potentially could do. And I would refer back to Mike Goodchild's talk this morning. He said something about the promise of geodesign. And then given the conversation that went on, the topic of the promise of CyberGIS came out. And I'm wondering if we're just making big promises right now. Is that where we're at? But nonetheless, let's start in with this first question here. Is there something that has recently occurred as an activity in the CyberGIS community or in the geodesign community which will perhaps fulfill some of that promise, or at least lead us toward some fulfilling of either one of those promises, and then the synergy between them maybe?
Okay, so I haven't really worked in the area of CyberGIS, even though I have been aware of its progress. But I have been, since I've worked in conservation planning and so on, which is really a geodesign application area. I have to say, I can give some, very briefly, some of the case studies, projects that we worked on that encountered, that we, at the time, realized we wished there's a high-performance computing platform that we could use. So, for example, Piotr just presented the sensitivity, the presentation on sensitivity analysis, and his co-author, Erika, was actually one of the collaborators in one of our projects for invasive species management for a military installation. So basically that project, the tool that we developed is prioritizing the weed patches which need to be eradicated or treated first, depending on a few dozens of criteria and sub-criteria. But in the end, after we did the ranking, we wanted to test to see how stable that ranking is. You know, whether if you change the weight on some of the criteria, whether the ranking still stands or you get a big flip-flop of rankings. So we did actually, with Erika's help, ran the sensitivity analysis, you know, developed the code and ran sensitivity analysis, which took a long time. And each time, of course, if you have a new data set coming in, because as with many projects, you don't always get a complete data set, and then data set keeps coming in, and in the meantime, you need to keep going. So anytime the new data set coming in, or some domain expert wanted to change some weight and so on, we have to rerun the sensitivity analysis, and that is always a burden. So definitely at that time, in fact, we even mentioned Xiaowen's name at the time, saying, well, maybe you could see where the CyberGIS platform, where that is, and asking for help. But that's one thing, and that's a past project. A recent project, it was what we call the LEAD project, is working again with Fish and Wildlife Service in Wyoming, where people are building windmills. Companies are building windmills, and we want to make sure they don't cause too much damage to golden eagles habitat, golden eagles being endangered species. So there are two parts of the model. One part of the model is basically doing a lot of calculations and coming up with where in the landscape is the most valuable habitat resources for golden eagle. Another part of the model is actually for calculating impact. Once you have a location for a windmill, and this part of the model can go into work and decide how much damage this particular windmill could cause. But that part model was never, it's implemented, but it was never used. And we are worried about the speed of applying it. While the Fish and Wildlife Service representative, you know, talking to the developer, and they were working out things together as to the location of the windmills. And ideally, if the developers say, we are planning to put the mill here, and put it on the map. And ideally, that part of the model would run and give us feedback saying this is how much damage, both spatially, area-wise, and also there is a number associated with it. This is the damage you are doing. Whereas if you move it to a different location, you might get a different impact analysis results. But that kind of to run that model, it will take a long time. It's not an on-the-fly thing, which would be ideal. So that, again, is, actually, that case is the most typical, I would say, urgent need, in my personal opinion, for CyberGIS, the help from CyberGIS, because one of the key definitions of geodesign is the tight coupling between design activity, sketching, for example, and the impact analysis of your design. And designers, when they are in a design mode, in a creative juices flowing, they don't really want to wait hours or even days to have one phase of impact coming back to them. They would rather have some dashboard coming up showing some analysis already and then continue to the next iteration of drawing. I mean, design is an iterative process. And so design analysis, a quick iteration, that's part of the definition of geodesign according to Mike Flaxman anyway. So the case, Golden Eagle case that I just cited is really shows a really urgent need for high power and high performance computing. I have another case, but I think I talked too long. So.
Thanks, Naicong. Clint?
Yeah, I can think of a number of things. First of all, just recognizing what's going on with computing and with GIS. Everything is now essentially a URL. Even if you're using information inside your organization and working across groups or departments, information access is really just like everything else on the web now. And GIS has always been both participatory and not exclusive. It's kind of all-encompassing. Mei Yuan's talk just a few minutes ago was fascinating, just to see other information starting to be spatially enabled. It's kind of amazing. What's happened with GIS is, and I've heard Mike Goodchild mention this before, is it's not we're all building our own GIS anymore. We're building the GIS of the world. That there's this kind of participatory activity going on. We've started to embrace that and look at that and think about how information becomes available. First of all, it's a lot more than just data. It's going to be all kinds of elements, maps, intelligent layers of information, analytical models that people can run. There's just all kinds of feeds of information that are going to be available. There's a few things that we've been working on, some of which that I think are quite interesting. Have any of you seen anything about the living atlas of the world in ArcGIS? If you just go into arcgis.com and find it and start to look at what's in there, especially in the thematic categories, it's a fascinating collection of the work of the GIS community, but that idea that people could create these kinds of collections of information for whatever kind of participatory thing they're doing, where they can begin to collaborate and share with one another, it's essentially just tagging information and trying to organize access to really good work. First of all, to just share it with the people that you collaborate with, and then longer term in other ways. You guys all, I think, are very aware of story maps, right? Story maps. One of the real recent ones that was published by a young student at the University of Texas. He's at the Center for research for water resources. He's from Peru, and he did a simulation of what might happen if a particular glacier had an avalanche. What would happen if this lake would flood? He ended up publishing a scientific paper about it, but the other thing he published in concert with it was a story map. And you can actually find that story map if you go out and look for his name, Denny Rivas. If you just search that in our blogs, I think you'll find it. It's a pretty fascinating narrative that kind of begins to open up access to that information. So I think it's kind of, and it's got some pretty amazing simulations and simulation results built into it. So it's both highly kind of scientific and very much of that simulation world, and that kind of not just collaborative information sharing, but that idea of collaborative computing, which I think CyberGIS is all about. But it's also this idea of really reaching out into the design and the response community about just how to track certain events. So those are a few of the things that came to mind for me when I saw this question.
Piotr.
Well, I'm not a member of CyberGIS project, but I consider myself as a stakeholder to CyberGIS, meaning I have definite interest in the developments. And so coming to this panel, I spent some time, went on the website of CyberGIS project, and I basically read. And so in addressing this first question about past or current activities in CyberGIS community, I selected two related directly to CyberGIS project, which in my view hold a promise for geodesign. Number one, CyberGIS Toolkit. Admittedly, it's a small collection of tools at this point. Many of these have been presented at this conference. But it's a good start. Second, GISolve as a middleware, which in my view is an enabling environment to allow others, people like myself, to start using resources. Admittedly, something could be done still to make GISolve more friendly to users, but again, it's a good start. So looking at these two developments, which are, in my mind, current developments in the CyberGIS community specifically related to the project funded by NSF, now I look at it from the perspective of geodesign. And so I find an interesting area for potential synergy between two communities at the intersection of collaborative geodesign, and this is the term that Mike articulated. Again, in my own recollection, I would refer to it also as collaborative use of geographic information systems and GIS tools, collaborative GIS. And then a geodesign framework as presented by Karl Steinitz. And at this intersection, I am focusing on these components 2 through 5. If you remember, these are models of processes, models of change, models of impacts, and I'm missing one in these 4. But let me cut through the chase and go straight to impacts. Why impacts? For the same reason that Naicong articulated, in my own experience, when one is involved in a collaborative situation, which is a creative act in many instances, when questions pop up, what happens if? These what-if questions. Sometimes they can be answered quickly, and we've seen examples of tools. There's a great tool recently developed by Esri GeoPlanner that we saw just yesterday that allows to quickly calculate consequences. But then there are questions that don't really lend themselves to these quick and easy answers. They require more in-depth computations. They're more challenging, but still there is need to answer them. So for me, to progress in this quest for better geodesign, or geodesign that deals with a more challenging situation, we need these types of tools. And so here there's an area of fruitful synergistic activities between CyberGIS community and geodesign.
Rob?
I have actually a slide that summarizes some of the things that were already said. And I'm going to address both questions together because I think they actually belong together. Okay. So I made a little chart, okay? And on the left-hand side, you see basically in the table description of the characteristic of geodesign. In the middle, what is that implication? And then on the right-hand side, what does that mean for CyberGIS? So characteristics of geodesign, I've already heard it's, you know, it's a multidimensional decision-making problem. This is how I would describe it, right? So you have various things that you want to consider at the same time for a problem, right? It can have complex implications that are have a high cost, for instance, if you get it wrong. You know, if you you want to adapt for climate change and you build the walls in the wrong place, you know, that might be a pretty challenging thing. And often it's characterized by many decision makers need to agree and not just one, right? So that's the collaboration kind of aspect. So and how is this addressed? In architecture at least, and all design disciplines that I know, it's iterative process, right? You try something, it doesn't work, try something else. You know, you need to get together a lot of different people from different disciplines that work at the same time. Oftentimes they ask consultants if they don't have the expertise, right? And then in the end, in a lot of these problems, you have to communicate that to a larger audience. So if you have a solution to build a dam, for instance, right, you have to convince people that that's the right solution, and everybody kind of needs to get on board. There's like this collaborative element, and that has often visual components. We've heard about scenarios, that you run different types of scenarios to see what the implications are, right? And oftentimes, that communication happens actually at the place of the client. So you may design in your little architectural studio, but when you present it, you go actually to the client and you convey that information, right? So this is, I just wanted to give a little bit of view of how could we characterize a problem and what kind of things. So in the middle, what does that mean? So for me, I think it means a lot of the things have to be very flexible. It's not, you know, there's not one solution for everything. And right now, we have these, the toolbox actually has domain-specific answers to some problems, right? So you have a tool, TauDEM, that does a certain thing. You have another tool that does a certain thing, right? If I have a geodesign problem, oftentimes I need several tools at the same time to convey my problem, because it's a complex problem. It's not a simple problem where, oh, it's just this and here's the answer, right? Oftentimes the answer is not simple. You have to have trade-offs between things to say what is the right thing. And oftentimes, actually, 100% of the times, people disagree about what the answer actually is at the end of the day, right? So you have to analyze several of these implications at once to get the holistic picture and not just part of the picture. And when you run scenarios, they're similar in similar locations. So for instance, if you analyze a watershed, yeah, it's similar, but the people there are different, so the context often is different, right? So you have to be able to adapt whatever you do to that context. You have to enable to integrate different users, you know, different team members that look at different aspects. There's no expert that can address the whole thing. Oftentimes you have expert teams, right? We talked a little bit about the speed of the computation. Now, I build a lot of decision environments, spatial decision environments, non-spatial ones, but out of psychology, we know that there's about a 10-second time frame until you say, oh, now you know, I can't do this anymore. I mean, you can observe this when you go to a dinner, right? And there's a conversation going on, and suddenly, for some reason, the conversation stops, count in your head. Before 7 seconds are over, somebody will say something, because there's this, this urge to kind of go on, right? Your brain keeps moving. So we usually formulate about a 10-second turnaround time. And I'll come to that later, what the implication is for us here. And then at the end, how do you present this? Yeah, you want rich visualizations, you want them fast, and you want to view them anywhere. So you want to take this along with you and whip it out when you are in the situation to talk to somebody that is relevant to that conversation. So, and how does that reflect to our CyberGIS? So for one, I think, start from the top again, data. So somehow right now we have models and services that do things, but my question would be, okay, how do we get the data in easily enough, right? And we had some discussions about this, so this more to serve as for us to start the discussion about these things. So if we had a data registry, how does this work? Do we collect data? I think Esri has a big effort, we heard about this, to collect like huge amounts of data. My experience is that's not always easy, because the people that provide the data or generate the data, they also maintain it. So how do we connect them to the effort, right, is the question. And then in addition to that, how do we discover this, and can we move it in real time into our analysis and discussions of geodesign, right? Okay, ability to combine a variety of services, that would mean some kind of workflow. Ability to connect to users in other domains. So if I talk about geodesign, I probably also talk about costs, right? Which suddenly I need to connect to a completely different domain, which is not necessarily spatial. But they're very important to make the final decision about the problem that you're talking about. And then you have to somehow be collaborative. I think it should be on-the-fly adaptable in some way, shape, or form. I don't have answers to everything, to how to do this. I'm just lining out where I think these are things that we should start thinking about, right? Adaptable user interfaces. I put there different type of computers because I think this relates to the 10 seconds. We have heard this yesterday to discuss, well, maybe we need a different type of computer. So for instance, we run a small cluster, about 1,000 cores, and we actually don't run it batch scheduled, because if I need to wait for my turn to be on the computer, the time that I need to kind of compute and convey the information is already over, right? So, so the question is, do we need to rethink how we do supercomputing in these kinds of environments of design? And you can also see it. Yesterday you demonstrated the planner, what is it called? The
GeoPlanner?
Thank you, the GeoPlanner, right? And there was a second where, okay, so here's the analysis, and then we're waiting to see the actual chart. And this was, I would say, it was not more than 3 seconds, maybe 4, right? But everybody's like, huh, what's happening? You know, people are, so it's like this kind of mobile access. I think we need excellent visuals to communicate what we're talking about. And then the last point is we need to cater to different classes of users and potentially at the same time. And this is in 2 dimensions, different classes of users in terms of domains, right? But also different classes of users that consume geodesign. So it might be an explanation to users, means to the general public, or it might be a communication between experts or something like this. So, so this is my little summary.
One of the main foci of the CyberGIS project is integration. And a number of the panelists have referred to this idea, and it's software integration. It's in the title of the program that funds the nature of the project here. And so we're looking at a opportunity to do a lot of integration, and Rob had referred to, there were a number of activities going on. I asked a question yesterday of Xiaowen about the big picture for integration, and the response has been, well, we've been doing nuts and bolts kind of integration here. So we've been doing software integration from the bottom up, is the reference made for 8 years. So there is an opportunity at this time to look a little bit broader. Now, in a project of this size, so it is a fairly larger project among projects that go on in the GIS community. So we've had the opportunity at this point in time at least to do a number of bottom-up integrations. But I think in the project, we're going to look more broadly across the project activity that we've done thus far and try and figure out a more general approach to the nature of integration that we do. And that's the one thing that's intrigued me about the geodesign framework, in a sense. It's an integrated knowledge production methodology. And that's really what I was referring to. Find me a better methodology that does knowledge production. You can, your own. But the geodesign framework is this community framework that's out there. It's been adopted by a number of people in a number of ways. And software has been written to this. And there are 6 different modeling, we would say, not really, 6 different modeling circumstances and situations that each in themselves are very different. But with that in mind, there's still a lot of opportunity out there. So what I'd like to do now is open up the nature of the questions and the discussion more to the participants that are here with us. Yeah, and for any topic in the nature, and thanks very much, Rob, for putting together that systematic perspective on some of the way forward here. And Steve, you're going to use that microphone, are you, for... Yeah, so any questions? David Tulloch has a question up here. Okay. Yeah, but if we end now, and I've normally done this, I've done a lightning talk in 3 minutes on this stage just before lunch, and I'm not doing that this afternoon. Sorry, apologize about that, but we will give 15 minutes back. We won't give a half an hour back. It's not just fair. It's just not fair.
So my question is Robert talked about examples where at the end we have these solutions. People may not agree about the solutions. We can agree that they don't agree, that there's not a right answer in design a lot of times. There's just design. And that's a really different final conclusion than what Piotr talked about in his talk earlier, which was, at least for much of it, you're talking about, there's some notion, whether ecologists fully believe this is true or not, they go along with this notion there's sort of this scientific, factual idea of the best place for those flowers to grow. And the uncertainty you're measuring is related to that sense of that. Okay? How does CyberGIS change when we're working towards things that we think of as explicitly knowable in fact, and things that are going to help us create something that we hope more people, well, I don't even know if we hope more people agree that they're better. Does that change CyberGIS? Does that change the way we think of the information we're supplying and the ways that it supports the analysis along the way?
Who wants to take that?
Okay.
Piotr?
I'm going to relate to your question not via my talk, but via a different issue, which goes back to that question number 2. What potential innovations are out there? And this is, again, nothing new. Since Mike gave such a comprehensive overview of the nature of the problem, I feel like I'm just left with repeating what he said, but I will try. In my answer to you, I think the problem is in dealing with multiple designs, with multiple answers, with multiple scenarios. And it's a problem of how do we integrate these multiple answers? How do we deal with that variety, with that variability in potential designs and potential projects? And it's a tough problem. It's a problem of data integration on multiple levels. There's an abstract level, different ways of representing that information, drawings, sketches, data tables, numbers. So it's a hierarchical problem of data integration in a way, or at least multi-level problem of data integration. How do we do this? I don't have an answer to this, but I see this as a research issue, as a research problem, and I think there are lessons to be taken from what is being done in CyberGIS concerning integration of from different services.
I'll also say a few words to this. So I think I agree actually completely with your notion, right? So at the end of the day, the question is, can you optimize it to get the solution? Is there a crystal ball? Or is at the end, we need to take some leap of faith to say, okay, that's it, you know, we're done. So we have actually tried a lot of these things where we combine everything, you know, and yeah, you get these outlines, but we had a little bit earlier conversation as well. So at the end of the day, you need to make a decision, right? If you do geodesign and you do something, you need to say, well, I plant the flowers at this point, I mean, right? So I invest the money at this place, whatever it is, right? And I would argue that almost all decision problems have incomplete information and are actually always somewhat, you know, into the blue. To be fair, some of these I have seen, you know, people walking on the golf course and say, that's what we're gonna do, you know, and they didn't have any support. So my argument would be a little bit more support is already a big step forward, you know. So if we catch everything at once, I don't know, then we probably don't need to make the decision. We can give it to the computer and say, you make all the decisions. You know, why do we have to look at it if we can come up with the best solution always, right? So I have a feeling, or at least my experience shows that there's always a little bit of uncertainty, and you just have to take that leap of faith. And if you look at leaders that make decisions, they basically, you know, oftentimes you have the feeling I don't know how they come up with these conclusions on decisions, right? It's just they make it. So, and I think the goal should be to give them as much meaningful information to help them to make good decisions, right, as we can. And I think this encompasses geodesign in general, be it an architect proposing a building and somebody has to say, okay, this is how we build it, you know, or be it that we decide where we shoot weapons in, you know, Iraq or something. It's all a problem that has a spatial kind of aspect. And I think the more we can use computing and supercomputing in a seamless fashion to give these bits of information, pieces, I think the easier it is for them to make meaningful and good decisions, you know, and not some that are not so good.
Clint?
You know, Peter, you talk about, you know, what you work on isn't a decision system, it's a decision support system, right? Right, and that idea that of geodesign, this idea that multiple points of view can be modeled and expressed and analyzed, I think is a key point about it. It's not like, you know, there's all kinds of contexts for how decisions are made, and sometimes it is two people on a golf course or somebody paying somebody off, or you know, a whole public process. But the idea that we can build systems and start to make information, not data, you know, not points of view, but information that we can generate that represent whatever it is that, you know, particular constituencies want, I think is a good thing. I think that allows us to just advance it somewhat as society, right? We just got to do those things.
Naicong?
I just want to second what Clint just said. So remember Carl Steiner's model. The last model is called decision model. There, different decision criteria will be at work for evaluating design alternatives, and these decision criteria come from early on of a geodesign process. It's solicited from the stakeholders and so on. So sure, all designs have some purposes and different people have different values, and I think some questions was raised earlier today about how, you know, different people's value systems come into play here. So I mean, as a decision support system or geodesign support system, that there are tools for recording people's criteria, what they want, and also the weight of each criteria, and also coming for helping people to come into consensus as to how much weight they assign to a criterion, and so on. And even if you cannot reach agreement on criteria weight and what criteria to start with, also, at least you can have different design alternatives. And then if you have really speedy, good impact analysis tools just to show the impact of different alternatives. And sometimes people propose something, they think this is really the best, really the way to go. And after they see the impact analysis, the outcome, they may change their mind. Okay.
Are there other questions? So while you're thinking of one, I have 2 comments related to that. Steinitz has identified 8 different paradigms of design. So there is just no single way to look at the idea of design. In terms of the way that we look at it, for example, here, is that if we look, and one of these 8 is Herb Simon's version of design. Now, Herb Simon wasn't a humanities, he was a psychologist, economist, and a computer scientist, all rolled into one. And his intelligence, design, and choice, he would say in the design phase, is really an assembly of information that you organize your ideas so that you can actually make a choice. That's the intelligence, design, and choice. So I would come back and say to Carl, actually decision model at phase 6 is not a decision model, it's a choice model. Because starting out with the representation, you've already committed yourself to a decision of some nature. You're going to do some space-time process modeling in the second phase, figure out how things are connected in the world. That's part of the decision as well. So all 6 phases really is about decision support modeling, really not decision modeling, because that's something else again, as it would be. So that idea of looking at design in a very open way is something we have to sort through. And I think there's a lot of opportunity to do that in CyberGIS. So it would be interesting to have a geodesign platform that could actually support all 8 different types of design. Because the thing about software, right, I mean, some of you probably thought before as well, why did you get into software? It's just this malleable thing and on with this glorious program that you've been writing. Oh, but wait a minute, next week I got to start another one. And then I got to do another one. And I got to put them all together, right? Imagine having, for the history of your life, in terms of where you're at, some of you would be a shorter career time frame, some of us a little bit longer, that you've integrated all of these software modules because you created them all. You designed or participated in it, you've created them all, and what comes out is some kind of knowledge integration statement about your life history. A space-time narrative about life histories to say what we've done there. But so geodesign in terms of maybe 8 different types of design. So we're looking at the promise of CyberGIS and the promise of geodesign maybe in the geodesign platform. There was a statement about such at the Geodesign Summit in 2013, and sort of the idea went away a little bit there. There was an idea simultaneously with the GIS enterprise approach, the geodesign enterprise. It's just too big of an idea right now for most of the community, perhaps. So the nature then of pulling together from CyberGIS and pulling together from geodesign is probably going to be a fairly rich way forward here. Geodesign being just a methodology, but yet, you know, what methodology has grabbed as many people out there as a single source of idea generation, which can be interpreted in so many different ways. Oh, it may be theory. Where's Mark? It may be theory and model as the 2 terms that could be grabbed in so many different ways and interpreted so many different, that it's a rich conversation environment to have for that stuff. Questions?
Hi, yes.
Britta, yeah.
So cartography online, and particularly for wayfinding, has been critiqued lately for being cookie cutter maps. Do you think we run the risk of moving towards cookie cutter CyberGIS? And if so, can you talk about that a bit?
Anybody want to tackle the cookie cutter part first? Because, you know, it's a metaphor.
Heck, I'll go for it. What the heck? I don't even know what my answer is going to be, but one of the things that I think I've discovered since Google came out with Google Maps and Google Earth was just the universal effectiveness of maps as a way to communicate. And I think it's one of the ways we all do it. And everybody started using it. Every decision maker has their cell phone and their nav system in their cars and so on. Just everywhere, people have really adopted the use of maps as one of these kind of key information items that they use. Every map has its own interface. And yeah, right now there's a lot of cookie cutter maps. But if you look at what's going on in the GIS and the geospatial community, and especially in CyberGIS, just stop and think about what a map is for just a minute. So a map is a window into all kinds of information. As the author of the map, you can choose what gets exposed through that map. That's pretty interesting if you start to think about it. That's not a cookie cutter map. I don't care what the graphic is. It's just this ability to kind of really deliver information in whatever way you want it to be. Maps can be used to tell stories, and there's many kinds of stories. Maps are how GIS people collect data. You know we all pour our data into the map. Yeah, it gets stuffed in some database somewhere, but we're using the map as a way to build all of this content. The organizations that you represent and the entire community, 400,000 plus organizations worldwide, are investing a heck of a lot in collecting real important foundational data. It's not Esri building it. It's a big community. It's millions of people out there collecting important information. Nobody can just go out and collect soils and hydrology. It's got to be real scientists. People can't collect demographic data, right? All that information's available. So maps can be used to display and interpret the results of analysis, right? Maps can even provide access to analysis. Maps can be invisible. Maps can be 3D. I don't think it's going to be a cookie cutter world. I think we're just seeing the beginning of it. I think there is a new kind of map that is that interactive map, and that map is a kind of an engine that really can drive a lot. And I think that's probably what excites me both about the CyberGIS threads that I've paid attention to over the years, and also with geodesign. It's that notion that, look, I'm a statistician. The reason I got into GIS is I thought finally there's a way to make sense of all this stuff. And that's what I think maps do, and I think they do a lot of things for us. I wouldn't sell them short. I would just say we're just seeing the beginning of it. And I think it's up to us to take some responsibility to kind of carry that forward into some kind of new dimensions and just a new world.
Rob, yeah.
Yeah, I would like to say something like to that regard as well. However, I want to kind of divert this a bit. So, cookie cutter, right? So, if we think about composing a complex problems out of small pieces, right? We're putting them all together. Now, with cookie cutter, I associate when I go to Nevada and everything looks the same, right? Which I think is not necessarily the case. It depends on how you design and how you compose these things. I feel that, so I've seen several projects that try to model the whole thing at once, right? So that would be the alternative, right? Instead of putting it in small pieces, you make it in once. And oftentimes that doesn't work because everything has to work before you can test it the first time, right? So the alternative approach is you put small pieces, right? And you can test every individual piece. And in this place, I think of CyberGIS services, for instance, right? So you can say, okay, this is okay, this is okay. Now, is the connection and the workflow of the whole thing also okay? It's a different story, but at least we have a way of approaching this huge problem, cutting it apart in smaller pieces. Now, in architecture, there are basically two design philosophies, right? So one is additive design and one is subtractive design. The difference is, if I build a house, I compose rooms and I just arbitrarily add rooms everywhere, right? And then you end up with a shape that is, I don't know what, right? Whatever it is, good luck. Or subtractive design, where you basically build the shell first and you say, this is what I want, and then you put the pieces in that you need actually for your building. So now, translating that, I think if we want to answer a question, for instance, in geodesign, I would go backwards, right? I first would want to know what is the question I want to answer, and then I want to look at what pieces do I need to support that answer, so that I can actually come up with a meaningful answer rather than adding things together, and at the end it's like, I don't know if I answered the question, right? So.
Our last question from Xiaowen.
Actually, two comments that are not necessarily all related. This is to address the opportunities with regard to the synergies between CyberGIS and geodesign. So number one comment is, you might have heard of this Design Innovation Institute, recently funded by Obama's government to Chicago and UIUC. This is $200+ million thing in the context of digital manufacturing. In that particular initiative, computational modeling, high-performance computing, in fact, played a major role. I understood that was a major component of the recipe winning that award. If I contrast that design, which is a lot of times related to product design in the manufacturing context, with geodesign, I tend to think geodesign even has higher stake, meaning that in product design, there's innovation opportunities, there's lower cost, there's performance to get to results quicker. But in geodesign, once you have a design implemented, it's very hard to turn or retreat. It's a reality given. The stake is high in a sense. Before you get to that reality, you really have to be careful with all the options possibly you could evaluate, and with all the engagement possibly you could push forward for participation and getting to the optimal end and the hopefully optimal designs. So computational modeling with high performance scientific support seems to be a very natural opportunity in geodesign. But given the legacy of GIS technologies and GIS science, we seem not have paved the way forward substantially. I see this is a major opportunity. It's not easy, as we learned from other scientific communities involved in the digital design I was referring to. This is decades of work. But I see if we don't start in a hard and aggressive and opportunistic way, we might lose a major opportunity for these synergies between CyberGIS and geodesign. Number two comment, this is about integration. What I learned about the vision of geodesign, I think that has a critical piece which is centered on integration. Integration of knowledge, integration of expertise of different kinds to put forward holistic designs. CyberGIS is built on the vision of integration. It's integrating, again, data models and analytics, cyber resources and services. So we seem to have a lot to learn from each other because they are supposed to be synergized to serve the purpose to come up with better geodesign plans. And they're not necessarily all separated, but where's that interface for fostering such holistic integration? And I think geodesign could fit very nicely the requirements, whereas CyberGIS could provide some intelligent and optimal support. And this is, to me, very much an opportunity of innovation and discovery. So any insights, feedbacks from the panel be much appreciated.
I just had one quick thought while you were talking, and I was thinking, I feel like some of what your guys' vision has been for CyberGIS is happening. It's not like we're anywhere near where we need to be, but I think the way the computing world is set up, the way geographic information works is fascinating. Everybody builds their little data sets for their postage stamp of the world, but it all fits into a whole. It doesn't matter what you build it with either, because they're all just becoming, map layers that everybody can use. Did you guys know in ArcGIS a year ago at this time, we were serving 1 billion base map requests a month. Last November, it was 1.5 billion. Last month, it was 4.3 billion base map requests. Just to give you a sense of what's going on, and it's a well-kept secret, it seems like, but there is this growth, and it really is about this kind of distributed computing environment. I think everything we can do to get, you know, more intelligent information into our systems, to work on collaboration about how we put those things together, to build on what you guys are doing. I think the opportunities, it's not just, I think, important that we do it, I think the opportunities are there as well. It's this really interesting time, I think.
How to exchange knowledge to even go to the further scales, right? To handling the complexity and the potential of such massive skill capabilities.
One last quick comment from Naicong, because I would like this panel to give time back to the program.
Okay. I'd just like to go back to the definition of spatial decision support that the SDS consortium came up with. So basically, for spatial decision support or geodesign support, there are two basic kinds, need-wise. One is informational support, one is computational support. By informational support, it means that, you know, suppose an urban designer started working, the design group started working, and wouldn't it be nice that you have an intelligent support system that as soon as I say, I am going to look at expanding parks in city X, and immediately you would, coming from the web or somewhere, the information about park design and history about this area X, city X, and so on and so forth. Case studies, somebody did something similar somewhere else. And so that's a knowledge discovery issue. Same discovery issue for tools. And like many presenters, I mean, several presenters said earlier, there are just tons of tools developed out there, one of a kind. But, you know, we don't want to always reinvent the wheels. If we can find something good, and then, but where is it? And sometimes the search result come back with dozens of tools for one purpose, but which one to use, and so on. So intelligent knowledge discovery would hopefully help narrow down, saying, oh, this particular tool is best suited for your purpose, depending on a set of criteria and so on. So that's just knowledge and information discovery part, informational support. And then computational support, we all just said, you know, we need high performance computing and so on, so that we can increase the speed of impact analysis, for example. And both of these knowledge discovery side of things and the computational support side of things, I think CyberGIS is just a really ideal platform to offer such help.
Will you join with me in thanking the panel?